Hi there, I'll be explaining the MOV instruction, which is the most important instruction while writing 8086 programming. So let's jump in. First you have to start writing our program by typing arg100h. So you don't have to worry about this. Next, so the basic MOV instruction. So if I write move, MOV, and if I say AX, you can write small ax also, no problem. AX comma, so if I write 56 AFH, say for example, so 56 AFH will be transferred to AX register. So pretty simple. Let's emulate it and see. Emulate. So and after I run the program, see in AX register we have 56 AF. Okay. Now the second type. Say if I write move AX comma 1000 H, and now if I write move bx comma ax, so what will happen is, so semicolon is not necessary. I added a semicolon by mistake in the previous example. So in this case, first I am transferring 1000h value into x, then ax value to bx. So always remember, right hand side value gets pasted to the left hand side. So, okay, so in this case 1000 will get pasted to ax, that means ax will be 1000, and in this case bx will be equal to ax, which is 1000 again. So I'll emulate, and if I run, see ax bx, so ax is 1000 and 1000, bx is copied whatever was there in ax. So let's go to the next one. So the next one, if I write move ax comma in brackets, in square brackets, if I write 1000h. So if I write simply 1000h, that means I'm transferring 1000h value to ax, and if I write inside square bracket, this means whatever value is in 1000h memory, that means in the memory location 1000, that has to be transferred to ax. So I'll show you. If I write emulate, sorry, if I click emulate and say I go to view memory to see the memory, and see, if you can see 0700 colon 100, so I want to go to the 1000th location. I type 1000 and update. So see, this is the 1000th location, this is the 1000th location, and 1001, 1002, 1003, 1004, and it goes on. Okay, now say if I write 78 AF here, and if I update, now if I run the program, so I'll dock it here, and if I run the program, just keep seeing the AX value. See, AX value is AF78. So basically what happens is, while you are storing it in the memory, it stores first the lower bit, then the higher bit. So that's why AF came first, then 78. So the next type is just the reverse of what we saw earlier. If I write move in square bracket 1000h and ax. So this means whatever value is in ax should be transferred to the memory location 1000. Okay, so before that we have to write something into ax. So if I write ax, move ax comma, say for now if I write 56 f3h, and now if I emulate and I go to view memory, now I go to 1000 is here, the first two blocks. Now if I run the program, see f356, as I told you, it gets stored in reverse, so 56f3 is stored here. One more important note, you cannot start writing these values with alphabet. Say if you write f6 3h, and if I try to emulate, it will show me an error telling that wrong parameter. So if you have like this, it should always start with a 0. So 0F6 F3H, it will be okay. Next one we will be using pretty often, so it's like move AX comma content in the memory location SI. So what this means is, say if I move SI comma, so I am using the SI register here. So if I write 1000H, this means I am moving 1000H to SI, and in the next step, so I am moving whatever is there is in memory location SI. So let me tell you again. Let me show you by an example. If I emulate and go to view memory, and if I go to 1000 update, and if I write say 6543 and update, and if I run the program now, see I got 6543 here. So this basically works like, first you transfer 1000 to SI. Now so while programming, 1000 will be transferred here. Okay, so 1000H will be transferred here. So whatever value is in 1000H will be transferred to AX. We will be usually using SI, okay, instead of, you can use BX also, but we will be usually using SI only for this purpose. Thank you for watching. Please subscribe for more.